Hello everyone, and this is your walkthrough for Worksheet 3C. This is for College Trig or MAT122. On Worksheet 3C, we're continuing the discussion of transformations of sine and cosine and other trig functions, but mostly on this worksheet we're going to be talking about just sine and cosine. Please remember that sine starts in the middle at your origin and then goes up to 1 and then goes back down to 0 and then down to -1, up back to 0, and it's kind of a wave that oscillates back and forth like that. Cosine is very, very similar, but instead of starting in the middle, it starts up top at 1 and then it goes down to 0, down to -1, up to 0, up to 1, and so on and so forth forever. So let's look at the beginning of this worksheet. Let's look at numbers 1 through 5. Okay, so number 1 says, what is the amplitude of this? Well, looking at our, just generalized transformation letters, we have the A out front, the H, the K, and all of these things. So for this one, the amplitude is always the number that's multiplying times either your sine or your cosine. So in this case, I said it's -5. You could have put +5. That's fine as well. I always include the negative, even though the negative is telling you more or not, if it flips or not. 5 is how high and how low the graph is going to go. So I put -5. If you put +5, it's fine too. Okay. Number 2, it says, what is the phase shift? Well, on this one, you have to be very, very careful because there is a 3 in front of that x. And before we figure out the phase shift, what we have to do is we have to factor out that 3 so that x is all alone. So if we factor out the 3, we're going to have to factor it out of that 18 as well. So if we divide 18 by a 3, you're going to get 6. It's still going to be positive. So a +6 there would shift the entire graph to the left 6 units. So the phase shift on this would be left 6 units. Okay, number 3 says, what is the period? So remember, for period, you need to figure out the K and then plug it into our formula where period equals 2 pi divided by K. So in this case, in front of that X is a pi. Well, if I factored out, that would become my K. And so I'm going to divide 2 pi by that K, which is pi. So 2 pi divided by pi, pi's cancel off. And so my period is 2. And don't forget, period, what that means is how long does it take for this sine wave to do a full up and down motion and get back to the beginning where it starts. So it's going to do that within 2 units. Okay. Number 4, we have the minimum. Now this is a trickier question than most people think. What we have to do is we have to take 2 things into consideration. The first one is this being shifted up or down? Is my whole graph being moved up, down, something like this? And then we have an amplitude on top of that. So for this one, the 30 out front, that's a +30. So we're moving this whole graph, the center line of the graph is being shifted up 30 units. So this one starts at 30, and then a typical one would go up 1, down 1 from there, but this one has an amplitude of 7. So it's going up 30, and then at that 30 line, it's going 7 above that, 7 below that, 7 above that, 7 below that. So for this one, if we're finding the minimum, it would be up 30 and then down 3 because that's the lowest part of our wave. So if you go up 30, down 7, you would end up at 23 is the minimum. Next one, maximum. Once again, we're taking both things into consideration, the vertical shift and the amplitude. So this whole graph is being shifted up 8 units and then has an amplitude of 10. So we go up 10, or I'm sorry, up 8, and then from that 8 line, we're going up 10 from that, down 10 from that, up 10 from that, down 10 from that. And so the highest point this will reach is up 8 for our vertical shift, and then our amplitude is 10, so 10 on top of that. So 8 plus 10 is 18, and that is what we get for the maximum. Okay? All right, so now let's look at number 7. Number 7 says we need to graph this from -pi to +2 pi. So when I'm setting up the scale on my graph paper or my little section of graph, I need to make sure that I go back to -pi and all the way up to 2 pi. I can't be any more, any less than that. So I counted by quarters of a pi, so a quarter pi, half pi, 3/4 of a pi, and then a pi. So that's why I space it out with 4 blocks in between the pi's. So that's how I set up the X scale. And then my Y scale, there's no amplitude change on this, so it's going to go up 1, down 1. So I knew that I had to go up to 1, down to 1, so I just, put that, I kind of spaced it out, counted by quarters so you could see the whole thing. Now this one is kind of tricky because inside the parentheses we're shifting, and it's going to be a shift of 1/4 of a pi. So we're shifting this to the right because it's negative pi divided by 4, to the right 1/4 of a pi. So the way I set up my graph is really, really nice for this because I counted by quarters of a pi. So instead of starting at 0, 0 like you normally do with a sine curve, I just shifted over 1 unit or 1/4 of a pi to the right, and then I just graphed it as normal. So I started in the middle and then went up to 1, back down to 0, down to -1, and then that's where I ended up. Now, it did kind of cut off in a goofy spot. It's not going to be a nice number where it cut off, but I just did the best I could to graph that. Now, if you wanted to get a really good value for that, you could make a table in a calculator and figure out exactly where that crosses. Probably, I don't know, a little over a half, maybe. But this is good enough for me, so I call that one done. Okay, so let's look at number 8. Number 8 has a lot of things going on. So the 4 out front in front of the cosine is going to be an amplitude. So we're going to go up 4, down 4. So when I'm setting up my Y scale, I didn't have any vertical shifts, so I knew I could go up to 4, down to -4, counting by ones. And then this one says go from -1/4 to +2 1/4. So I just counted by quarters because I had enough graph paper to do that. So that's how I set up the x-axis scale on that, and you can see what I wrote on there. Okay, so now I need to figure out, there's going to be a horizontal shift, and I don't know what that is until I factor out that pi. And then that pi that I'm factoring out is going to be my k value, which will lead me to a new period. So I factor out the pi. The pi is the k, so I divide 2 pi by that pi. So 2 pi divided by pi, pi's cancel off, you get a period of 2. So this is going to do a full up and down motion within 2 units. Okay, so that's your period. And now the horizontal shift, we get a +1/4. Okay, so what that means is we're going to shift it to the left just a 1/4 unit. So what we're going to get here is we're going to get a graph. Typically, a cosine graph starts at 1, and so we're going to shift that all to the left 1/4 unit. So if we do that, all right, so what we get is instead of starting at 1, 0, or I'm sorry, 0, 1, so 1 on the y-axis, we shift that over to the left 1/4 units. And so that's my starting point. And then I knew it was going to do a full wave within 2 units. So I kind of counted by quarters over to the right to get that other peak. And then once I have that, I cut it in half, and that's my valley or my lowest point. And I put that down at -4. And then I know to get from my peak down to my valley, I have to cross the x-axis. And so that I count kind of halfway in between those. And that's how I got the x-axis there, and then the x-axis to the right. So you do your best to connect all the points with a nice wave shape, and this is what you should end up with on number 8. Okay, let's look at number 11. So number 11, there's a lot of stuff going on. We have a 6 out front, and that is going to be a shift of the entire graph up 6 units, and then we have a amplitude of -4, and what the negative is going to do is reverse it, so that it is going to, instead of starting up top, it's going to start on bottom, and then the 4 is going to make it swing up 4, down 4, up 4, down 4. Now inside the parentheses we have a 4 in front of the x, so that is exactly what we have to factor out. So if we factor out that 4, the 4 will go out front, and that's our k, so we divide 2 pi divided by 4, and you get half a pi for your period. And then what's left over, when you divide pi divided by 2 divided by pi again, you get, or divided by 4, you get pi divided by 8. So that means we're going to shift this entire graph over to the left 1/8 of a pi. So now when we set up the scale, they want us to go from negative half a pi to positive pi. So I cut this up into eighths because I knew I was going to be shifting this to the left 1/8 of a pi, and I wanted to have nice units to do for this. So that's what I did here. And the starting point on this, like we said, is going to be shifted to the left, and it's also going to be down. We're going to be starting on the bottom because it's negative 4 pi. So we go down 4, start with our dot, and then swing up, swing down, swing up, swing down until we end up at pi. And this is the graph that we end up with for number 11. All right, so looking at number 12, says graph the following on the same coordinate system. What do you notice? Well, y equals sine of x. I'll start with that one. That one's in green. We start in the middle, we go up, we go down, we go down, we go up, and we do a full cycle or a full period within 2 pi. We go up to 1, down to -1, like we normally do. So that one's really, really easy, okay? The cosine of x minus pi divided by 2, so that's just a regular cosine graph, but it's been shifted over to the right half a pi. So if I have my initial starting point at 0, 1, I'm going to shift that to the right half a pi, and that's going to get me to the exact same point where sine of x goes through. And I go down, I go up, I go down, I go up on the left side. And so what you'll notice if you graph both of these is they're the same exact line. So, if you shift a cosine curve over to the right, you can make it look exactly like a sine curve. And same thing with the sine curve. You could shift it either left or right and make it look identical to a cosine curve. So, I don't know. That was something to see, I suppose. All right, last section. What they say is find the equation for the trig function that satisfies all these conditions. So they want an amplitude of 10. I did that here in blue. And it doesn't say anything about sine or cosine, so I just use sine. If you use cosine, that's fine too. But amplitude of 10, so that goes in front of the sine. So they say they want a period of 12. Well, that's in red. Let me show you what that looks like. Over here on the right, we say 12 is the period, so that's the 12 equals. And then it's going to be 2 pi divided by some k. Well, we got to solve this for the k, and that's what we're going to stick into our equation. So if we solve this for k, you're going to end up getting 2 pi divided by 12. And if you reduce that, that's just going to be 1/6 of a pi. So that's what I put in front of the parentheses. And then they say they want a phase shift of -2. So I switched the sign, put it in parentheses, call it x plus 2. And that is the entire equation. You could distribute the pi over 6 into the parentheses if you wanted to, but I think it's a lot easier to read if it's in this form. So that's why I left it like this. Make sure you're not forgetting that period formula, the 2 pi divided by k. Okay, and then that's how you're going to do all these. They'll all have some type of phase shift, so you will have to solve that, period formula over to the right somehow. Okay, so that is it for Worksheet C. If you should have any questions or see any mistakes on my work on the answer key, please let me know, because I found a bunch of them and I corrected them as I went. But mistakes happen. So let me know if you have any questions, and good luck on this worksheet. If you want to bring some questions to class, that'd be great too. I'd be happy to answer them for you in class. Okay, have a nice day, and I will talk to you later.